All right, hello everybody. Sorry I couldn't be here today, but here are the notes that you need to finish 5.1 finally. Um, this will focus on using the calculator to answer many questions, increasing, decreasing, min, max, um, maybe even to factor. Okay, so this is stuff that we've done before, but now we're going to apply it specifically to the polynomials that we've been studying. If you forget how to find the real zeros, which we've already done, but if you've forgotten how to do it, it kind of walks you through how to do it right here. And if you forgot how to find the turning points, remember that that's either max or min, right, depending on what it looks like. All those steps are written out right here for you, okay? So let's just go through the first problem. The first problem we have this polynomial right here, f of x, and we're going to type that into the calculator so we can start answering the questions once we have a good graph. Okay, so if I go ahead and type that in, x cubed minus 0.8x squared minus 4.6656x plus 3.73248. If I hit graph, obviously I need to change my window. So a good place to start will be zoom 6, zoom standard. Let's see how that looks. Actually, that's a pretty good picture right there. So let me just kind of sketch it off to the side here so we have a reference when we're answering these questions. We have a turning point up here somewhere, turning point down there. It looks kind of something like this. Okay, so now let's see if we can answer the questions. What is the degree of the polynomial? Well, since it's already multiplied out, remember that it's just the largest exponent, so that'll be degree 3. And whatever the leading term is, that is the power function that pretty much resembles the graph. So right here, it's just going to be x cubed. Okay, if this were a negative x cubed, then the graph would be reversed and it would look like negative x cubed, the backwards cubic graph. All right, so x-intercepts. Well, if you forget, up here on the left tells you how, but I'm going to go ahead and find the zeros. Okay, so looks like there are 3 of them. To find the first one, you go to 0, and just make sure that you're to the left and to the right of that x-intercept right here. Looks like the first one's negative 2.16. So I'm going to put that down right here and label it. Negative 2.16. And then I'll find the other ones, same way. Make sure you're to the left of this x-intercept and then to the right of it. And then hit enter. Looks like this one's 0.8 right here. And then this last one, if you go ahead and find that one, it's 2.16 positive. Okay, so I'm going to write that down now. So we have 3 x-intercepts, negative 2.16, 0, 0.8, 0, and 2.16, 0. Remember, I think for one of these you might have seen, I don't know if it was, let's see, was it this one? Nope, that was okay. Might have been the first one. I remember seeing this and I didn't talk about it, but oh, it actually worked out okay. If for some reason on your calculator you see something like negative 2e minus 8 or, for the y value, that's really just saying 0. Remember the scientific notation. Sometimes the calculator has rounding issues when it's doing the zeros or the max and min features, so just be careful with that, but those are the zeros. Okay, now for the y-intercept, it's probably easiest to just do this on, do it without a graphing calculator. We find y-intercepts the easiest way usually is just to plug in x equals 0. So if you go back to the original equation, when you plug 0 into x, this term will be 0, that'll be 0, that'll be 0. The only thing that we're going to have is this 3.73248. So that'll be the y value. Okay? So 0, 3.73248. So that's the y-intercept. Okay. Now to answer D, intervals where the graph is above the x-axis. So if I'm looking at my graph, the graph is above, remember this is x, this is above the x-axis from here to here, and from here to here. Okay, so these little sections right there. Remember, when we're doing intervals, we're always doing x values, right? In other words, from what x value to what x value are we above? So for the first interval, we are from negative 2.16, that's the first x value, and we stay above the x-axis until we get to the next x-intercept, which is at 0.8. Okay, and then looks like we're above the x-axis again, starting at x equals 2.16, and then we never come back down, so that's going to be to infinity. Okay, and now below the x-axis, below would be this part of the graph and this little piece right here. Okay, so below, remember we're starting from the left of the graph at negative infinity, and I stay below until I get to this x value here at negative 2.16, and then I go above and I dip back below from x equals 0.8 to x equals 2.16. Okay, and we're using parentheses for all these intervals because at these actual values we have 0. In other words, we're on the x-axis. If we are just above or just below, we don't want to include those values. Okay? All right, turning points. You guys have found those before, so that shouldn't be too bad. Looks like there are 2 of them. Turning point right up here, turning point right down there. To find this first one on the left, since it's a high point, we're going to use the maximum feature. And right here, it looks like it's a low point, so we're going to use the minimum feature. Okay, so on the calculator, now we're going to go to that same menu that we've been using all the time. The first one's a max, so I'll go to maximum. And again, just make sure you're to the left of this high point right here, and then get over to the right of it. Hit enter a third time, and it looks like the first x value, I'm going to round to 3 decimals here, negative 1.00, you know what, I'll just do the whole thing, 86, and then this is about 6.5983. So I'm doing 4 decimals here. Okay. And now, to find the lower, the lower turning point, sorry, we're going to do the minimum feature. Again, make sure you're to the left and to the right. And looks like we are at about 1.5419 and negative 1.6976. Okay. Ooh, excuse me. So let me label. So this is negative 1.0096 6.598 right up here. I'm going to round to 3 decimals, sorry, running out of space. And this one was 1.542, negative 1.698. Okay, so once we have those values, now we can answer increasing and decreasing questions. Again, these are intervals, so we're looking from what x value to what x value is the graph going up. Well, we're increasing the start. So from negative infinity, we're going up, and we keep increasing until we get to this first turning point, which is at about negative 1.009. Then we start to decrease from negative 1.009 until x equals 1.542. And then from 1.542 and on, we are increasing. So we're also going to be increasing from 1.542 to infinity. Okay? So lots of details here that we should be able to answer now with the graphing calculator. Domain and range, though, I mean, you guys should know that from what we've talked about before. The domain, just by looking at the picture, is all real numbers, and so is the range, right? From left to right, we have no discontinuities. We hit everything. Same thing and since the graph goes from bottom all the way to the top, we have all real numbers for both the domain and range. Okay? All right, example 2. Type the equation, so another equation, and we are just using the standard window here. So let's go ahead and do that. X to the 5th minus x to the 4th. Oop. Plus 5x to the 3rd minus 2x squared. Okay, there we go. Okay, so looks like there's maybe just one x-intercept here. Let's go ahead and use this new technique here. Zoom box. Okay, we see that there is a x-intercept right around there. Ooh, I haven't really, let's try this again. Ah, okay, so you literally have to make a box here, and I didn't do a very good job. So let's try this again. I'm going to go back to the standard window, zoom 6. And what we're going to do is tell it exactly where to zoom in by making a little box. So if you go zoom box, go left and up, so I can actually, that'll be like the left top corner of my box. And then if you go down and over to the right corner, now it zooms in for us. And right there you can see it does look like it hits 0, but then it goes just a little bit below the x-axis, and then it comes back up and hits the x-axis again. So it looks like there's 2 x-intercepts here. Let's confirm. So it looks like there's an x-intercept right around there, so we're going to go left bound, right bound, using the zeros feature. And sure enough, we do get, well, we should. I don't know what it's taking so long. No sign change. Interesting. Oh, that's correct. So now why could that be? Well, because if you look at the graph, it looks like it goes up to 0, but it never really goes up. It just bounces off, kind of like a parabola does, like the graphs we've been studying. You can confirm that 0 is one of the x-intercepts by actually just looking at the table. You can see right here that 0, 0 is on the graph. Okay, so that is one of the x-intercepts. The other thing too, and we can talk about this more later, but if you try factoring this, the very first thing you would do is take out an x squared. And so just by taking x squared and setting it equal to 0 by hand, and then square rooting both sides, you see that 0 is one of the x-intercepts. Okay, now to find the other one, we go to the zeros feature. Make sure you are to the left and to the right. And then we get about 0.420, 0, 0. So those are our two x-intercepts. And I think we've pretty much answered the question here. So there are two x-intercepts, and we've already found them both. So that'll be the answer there. Okay. Now, usually I would ask if there are any questions right now, but I wouldn't be able to answer them. So hopefully, if you need to stop the video, you can, and maybe you can help each other out, but I'll go over any questions you guys might have tomorrow, okay? Let's go ahead and go on to the next page. Page 8. Okay, put the calculators away for the time being. Now we're going to talk about working backwards to make polynomials. Okay. So if we're given the zeros or the x-intercepts or roots, these are all the same thing, by the way, we should be able to work backwards to find the factors, right? So if -1 is a 0, that means x plus 1 had to have been a factor, right? If 1 is a 0, think backwards, that has to be x minus 1, right? And if 8 is a 0, x minus 8 has to be a factor, okay? The degree is 3, and it looks like that we have everything we need here. So now this is the linear factors form right here. When everything's written in terms of linear factors, okay? That's what we mean by linear factors form. Now to find the polynomial, we're always going to write our answers in standard form, so we're going to actually have to go ahead and multiply this out. Okay, so I would just take these first two, multiply those together. If you don't remember the difference of squares pattern, you can FOIL the long way. But you're going to see that after you do x times x to get x squared, when you do x times -1 and then 1 times x, those middle terms cancel, and then all that's left is 1 times -1. So we have x squared minus 1. And then now, we're going to take that and multiply it with x minus 8. So yes, be very careful. You're going to take x squared and distribute it to both terms here. So x squared times x is x cubed. X squared times -8 is minus 8x squared. -1 times x is now from the third term. And then the last term would be -1 times -8, which is positive 8. And so we can write x cubed minus 8x squared minus x, you don't need the 1, plus 8. Okay, and technically, we're not told anything else, so we don't really know what the leading coefficient is. So what we're going to do is just leave this as an a value. It could be a 1, it could be a -1. It can't be 0 though, okay? But it could be some other real number, okay? So this is the leading coefficient, which we don't know and we don't have enough information to find. Okay? Now, I would maybe pause the video here and maybe you guys try this one, B, example 3B on your own, similar to part A, and see if you get the same answer I did. Okay, now, once you've tried it, or maybe you're just waiting for me to do it, I mean, you guys tend to do that anyway, let's work backwards and write all our factors. So if 0 is one of the x-intercepts, that means x minus 0, which I'm not going to write, In other words, just x is one of the factors. 2 means x minus 2 is a factor, and negative 5 means x plus 5 is a factor. The degree is 3 again, so we're just going to multiply this out. Take the first two, multiply those together, you get x squared minus 2x. And now distribute that to x plus 5. You're going to get x cubed plus, actually let me write it up here because I think there might be some like terms. X cubed plus 5x squared minus 2x squared minus 10x. So it looks like we can combine the middle terms here for this one. So x cubed plus 3x cubed squared, 3x squared minus 10x. And again, this is all times some leading coefficient not equal to 0 that we don't know. Okay, but it needs to look something like this. Okay, so this is linear factors form. That's where we start. When we multiply everything out, this is called standard form down here. Okay? All right. Now, let's look at example 4. And now the graph's already done for us, but if the graph is not done for us and they're telling us to use the graphing calculator to factor, this is actually really neat because you can do this really fast. You don't have to do any algebra, really. You just look at the picture. Okay? So, first, let's talk. They don't ask us to, but I'm going to write down the degree up here. Notice that it starts up, ends up. This is what parabolas do, right? So that means that the degree here is even. It has to be an even degree. Okay? And now, the smallest degree possible, I'm just going to look at the picture here. Right here at this -6, we have a multiplicity of 2. We could argue that it may be 4 or 6, but I'm going to just keep it as small as possible. Okay? Remember that if it bounces and just touches the x-axis but does not go through, that this is an even. Typically, it's degree 2 for the multiplicity. The next 0 is right here at 0. It looks like the multiplicity is 1 since it's just going through. It's not wiggling its way through, so to speak. And then over here at 7, same story. It just goes straight through 7. Okay, so here you can see, if you add the multiplicities together, that the smallest degree possible here is 4, which confirms the picture because degree 4 is even. Okay, and so now to factor, just work backwards. Since there's a 0, I'm going to start by putting an x in front. And this is to the first power. I'm not going to write the 1, but it's to the first. Okay. The next 0 I have is -6, so that means x plus 6 needs to be a factor. And since it's a multiplicity of 2, then that means this will be squared. Okay? And now we also have x minus 7, since 7 is a 0. So here is your polynomial factored out. And we just looked at the calculator or looked at a graph, but you can see how we can use the calculator to factor if it factors nicely. Okay? All right. Last problem. Determine whether the graph could be the graph of a polynomial function. So let's talk about that first. This graph is nice and smooth. There's no cusps. There's no discontinuities. So I do think it could be a polynomial function. So yes. And you can see that it has an odd degree since it starts up and ends down. Okay? Now looking at the picture, it looks like there's a few zeros. We have 1, 2, 3, -4 is a 0. Looks like -1 is a 0. 1, 2, 3, +4 is a 0. And 6 is a 0. And based off of the pattern that we see here, since it's going straight through at negative 4, there's no multiplicity column, but I'm going to write it down anyway. Multiplicity there is 1. Multiplicity at negative 1, since it's bouncing or just touching, is 2. Multiplicity at 4 is 1, and the multiplicity at 6 is 1. So the least degree possible here is 5. Okay? And it should ask you to factor it. And also notice that the leading coefficient has to be negative because it starts up and ends down, right? So remember that pattern. And now as far as finding the polynomial, let's call it g, we can write it in factored form using these zeros. If negative 4 is a 0, that means x plus 4 is a factor. Multiplicity is 1, so that's good. Negative 1 is a 0, so x minus 1 is a factor. Multiplicity is 2, so that's got to be squared. And then we get from 4, we get x minus 4. Multiplicity is 1, so that's good. And then from 6, we get x minus 6. Multiplicity is 1 there. Okay, and we do have some leading coefficient, and all we know is that it's negative. Okay? Has to be negative in order to get this picture. Okay? So that wraps up the notes for 5.1. Please use the rest of the time here to work on Math Excel. And I'll also have the sub hand out the practice packets now. So if you're done with Math Excel or you're finished pretty soon here, you can start working on 5.1 in the packets, okay? I'll see you guys tomorrow.